In this video, we will learn about differentiation rules. These are all the differentiation rules you will need to know in your Calculus 1 class when you are differentiating. First off, the term differentiation is equivalent to the word derivation. They both refer to derivatives of functions, and as a reminder, the derivative of a function gives the instantaneous slope, or the slope of the tangent line at a given value x of a function in terms of x. So there's the constant rule, the power rule, the constant multiple rule, the sum or difference rule, the chain rule, the product rule, the quotient rule, and trig derivatives. So let's jump right into it. So first off, the constant rule gives that the derivative, denoted like this, of any constant c is equal to 0. So that is the constant rule. So for example, if f of x equals 3, the derivative of this function, denoted as f prime of x, is equal to 0. Next up is the power rule. Now, the power rule states that the derivative of a function of the form, the derivative with respect to x of a function of the form x to some power n, where n is an integer, this derivative is equal to n times x to the n minus 1. Now an example, if we have the function f of x equals x to the 7th, the derivative f prime of x is equal to 7 times x to the 7 minus 1, which is 6. So 7x to the 6th. Next up is the constant multiple rule, which states that if we have a function that looks something like this, if it looks like some constant c times some function u, the derivative of this function is of the form c times u prime, where u prime is the derivative of u. Now an example is if we have a function that looks like this, f of x equals 4 times x to the 5th, f prime of x will be equal to 4 times 5 times x to the 4th, which is equal to 20 times x to the 4th. The next one is the sum or difference rule, which states that if we have a function that is of the form of like this, where the function can be represented as, say, u plus or minus v, where u and v are both functions of x, then the derivative will take the form of u prime plus or minus v prime. An example of this would be if we have some polynomial like this, we just take each respective derivative of each term. So in this case, if f of x is equal to x to the 8th plus 2 times x to the 3rd minus 7x plus 12, f prime of x will be equal to 8x to the 7th plus 2 times 3, which is 6, and then x to the 2nd minus 7, and then plus 0, which is just equal to 8x to the 7th plus 6x squared minus 7. So that is the sum or difference rule. Next up is the chain rule, which basically says if we have a function that is composed of another function of x, so it can be represented like this, f of u, where u is a function of x and f is a function of u, the derivative would take the form of f prime of u times u prime. So an example of this would be if we have the function 2x to the fifth minus 5x cubed plus 12 all to the fourth power, f prime of x would be equal to 4 times 2x to the fifth minus 5x to the third plus 12 all to the third power times the derivative of the inner function, which is 10x to the fourth minus 15x to the second plus 0. So this would be the derivative. This would be f prime of x. The next example is the next rule is the product rule, which says if we have a function that is of the form u times v, where u and v are both functions of x, this is equal to u prime of v plus u times let me rewrite this. If we have a function that is of the form u times v, where u and v are both functions of x, the derivative will be equal to u prime times v plus u times v prime. And to extend this to a product of more than two factors is if we have a function of this form, u times v times w, the derivative of this function would be u prime times v times w plus u times v prime times w plus u times v times w prime. So you kind of go down the line with the respective derivatives of each factor. So an example of the product rule, if we have a function f of x is equal to 2x to the fourth minus 3x quantity times x cubed plus 7, f prime of x will be the derivative of the first factor, which is 8 times x to the third minus 3 times the second factor, x cubed plus 7 plus the first factor, 2x to the fourth minus 3x times the derivative of the second factor, which would be 3x squared. This would be the derivative. Now the next rule is the quotient rule, which says that if we have a function that is of the form u over v, where u and v are both functions of x, the derivative here, I like to remember a little song for the quotient rule. It goes low d high minus high d low. Don't forget to square the low. So low d high, that would be v, and then d high is u prime. And then minus low d high minus high d low, so that would be u. D low would be v prime. And then don't forget to square the low. You just square the v. And the derivative of this function would be this. So an example, if this was the function, then f prime of x, we could sing the song, low d high, so that would be x cubed, d high, that would be the derivative of the numerator, so that would be 18x minus 2, and then minus high d low, so we just rewrite the numerator, 9x squared minus 2x minus high d low, the derivative of the numerator would be 3x squared. And then that would be our numerator. Our denominator would be, don't forget to square the low, that would be x cubed squared which would be x to the sixth. So this would be our derivative for this function. Now, I'm going to go on to the trig derivatives. Now, these kind of just require some amount of memorization. I will give them all to you now. So the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. The derivative of secant of x is secant tangent. The derivative of cosecant of x is negative cosecant cotangent. And the derivative of tangent of x is secant squared of x. And the derivative of cotangent of x is negative cosecant squared. Those are all the trig derivatives. And yeah, that is basically everything you will need to know for differentiation for your calculus